Okay, so I'm going to talk about reactions of monosaccharides. So there's several important reactions to monosaccharides that is talked about in your book. I'm just going to really talk about the first three. I'm really going to emphasize these three, and really only a specific couple aspects about oxidation reduction. And furthermore, oxidation reduction is something we've done before. Glycoside formation is something that's also pretty important, so we'll talk about those. I'm going to save phosphate ester and amino sugar formation until another time. So you can get three different types of sugars from oxidation of monosaccharides. So it depends on what we use as our oxidizing agent. We use weak oxidizing agents. These are like Tollens solution, a Benedict solution, a Felling solution. And we know that if we have so if you think about a ketose, right? So ketose, I'm actually going to draw it out, right? Here's my ketose. I'm not even going to draw quite everything in, but what happens is if we oxidize a weak oxidizing agent, right? And we know this. We learned this back when we talked about alcohols. We oxidize aldehydes to carboxylic acids. So aldoses get oxidized to carboxylic acids by mild oxidizing agents, like what we find in Tollens and Benedict solution. So it only oxidizes the aldehyde end of the aldose to give an aldonic acid. I don't care if you know that name. It's just aldose becomes an aldonic acid. The term reducing sugar is a carbohydrate that can be reduced by Benedicts or Tollens. So it's something that can be reduced by a mild oxidizing agent like Benedicts or Tollens. So here we're talking about aldoses. So aldoses are definitely reducing sugars. However, it's interesting to know that under basic conditions associated with these reagents, so Benedicts and Tollens both have strong acids or strong bases in them, and they're very basic. There's this rather complex, we're not going to go into the specific chemistry of it, but rather complex reorganization where ketoses rearrange themselves to become aldoses. And really, I can show you what happens. If you imagine it, what we do is we basically just get sort of a hopping of the electrons. It's way more complicated than this, but what happens is basically we swap. This swaps over, and we get, this turns into the carbonyl carbon. So what happens is under really basic conditions, the ketose becomes an aldose. So what happens is ketoses are also reducing sugars. So all monosaccharides are reducing sugars, even when they're in their ring form. And the reason that happens is because, so here's my hemiacetal. It's important to know that these are always in equilibrium with the open chain form, right? The ring structures, both alpha and beta form, are in equilibrium with the open chain. So only like 0.1% or 0.01%, a very small amount of the solution at any given moment is the open chain form. But the thing about equilibrium, if you remember back in 121, we talked about Le Chatelier's principle. If this starts reacting, it pulls the equilibrium to it. So if you remove the open chain aldehyde, then you start getting more open chain aldehyde replacing it. What ends up happening is everything ends up reacting. So both aldoses and ketoses, any monosaccharide is a reducing sugar. In fact, anything that has an open or has a hemiacetal on it can open to become a reducing sugar. And we'll talk more about and we'll talk about disaccharides in a little bit, but all monosaccharides are reducing sugars, and this is what ends up happening. So even ketoses become carboxylic acid. So we turn to become acidic sugars. Now if, on the other hand, we add a strong oxidizing agent, right? There's something else here that can be oxidized. Actually, there's lots of things here that can be oxidized, but it turns out that these alcohols don't get oxidized, but this primary down here definitely gets oxidized. So if you have a strong oxidizing agent, both ends can get oxidized. So see, what happens is you have a strong oxidizing agent. It definitely oxidizes the very easy to oxidize aldehyde. But the primary alcohol first becomes an aldehyde, and then it becomes a carboxylic acid. So it goes through a two-stage thing, but strong oxidizing agents just react very quickly, very aggressively, and turn it right into a dicarboxylic acid. And here's the thing. These are things you already know. You may not have really known the difference between what a weak and a strong oxidizing agent do, but you knew that primary alcohols could go and become carboxylic acids. We can also oxidize by enzymes. Now, enzymes are very specific structures, and we're going to talk about them next. We're going to talk about them soon. And just know that you can get an enzyme doing something funny, like oxidizing only the alcohol end to make oxide. You only get that from enzymes. You're not going to get that in a lab by just dumping oxidizing agent in it. Okay, reduction of sugars. I'm not going to focus on this that much. It just goes the other way. You can reduce the aldehyde back to a primary alcohol. Okay. And that's really all. The main reason we talk about oxidation and reduction of sugars is because there's an important idea of what a reducing sugar is. And one of the primary tests for sugars are Tollens and Benedict's, is to test for reducing sugars. And so that's how we test for the presence of sugars. Now, glycoside formation is important in understanding how disaccharides are made. Glycoside is an acetal. Fundamentally, it's an acetal. So what you get is you get a cyclic monosaccharide with an alcohol. So we can make a glycoside by taking, so here is a cyclic, not very well drawn, but a cyclic form of a monosaccharide. Here's my hemiacetal. And remember, under acidic conditions, this is what we talked about back in our previous chapters, I think it was 16, you get the alcohol attaching itself to the hemiacetal carbon to make an acetal. So you see how this carbon has OR and OR going this way. So that's all a glycoside is. I'm not going to talk about, your book talks a little bit about how to name them and all that, but that's not really here nor there. What's really important for glycoside formation, really the things to know out of here is, what does it mean to be a reducing sugar? So if it has an aldehyde, if it's an open form with an aldehyde or a ketone, or if it has the hemiacetal carbon, then it is in fact a reducing sugar. Glycoside formation, it's just important to know that we can attach alcohols onto the hemiacetal carbon and make acetals. And I'm going to talk about that in the next presentation with disaccharide formation.